Hi guys, this is your Skeletal System Notes with Miss Hale. As we already reviewed, the function of the bones is to support the body, to protect the body, to provide the body with movement, for storage. Not only calcium is stored in there, but also fat and other minerals such as phosphorus are very important. And there's also functions in blood cell formation, and which occurs in the bone marrow. And the other name for that is called hematopoiesis. There are two major types of bone, compact and spongy. Compact is very dense and looks very homogeneous or all the same, whereas spongy is small, needle-like pieces of bone and open space. There are four shapes of bones, and the shape really relates to the function of the bone. So long bones are longer than they are wide. They have a shaft with a head at both ends that's a bit wider, and they're made mostly of compact bone. And so your femur and your humerus are both examples of long bones. Short bones are cube shapes, mostly spongy, and so two examples of this are your carpals and your tarsals. And flat bones are thin, flat, and usually curved. They are two thin layers of compact bone that sandwiches spongy. Examples of this are your skull, your ribs, and your sternum. And then irregular bones don't fit with any other category. And two examples are your vertebrae and your hip bones, as well as your sphenoid bone, which is in the base of your skull. The gross anatomy of a long bone, gross anatomy meaning what you can see without using a microscope, is a shaft called the diaphysis, and that's what makes up most of the length of the bone, and that's made of compact bone, which is covered by fibrous connective tissue called your periosteum. And then perforating fibers or Sharpie's fibers secure that periosteum to the diaphysis. At the ends of the bones, you have epiphyses, which are made of a thin layer of compact enclosing spongy bone. And those are covered by articular cartilage, and articular cartilage decreases the friction at your joints. It's made of hyaline cartilage, which is very glassy and smooth, which is how the friction gets decreased because of the smoothness of the cartilage. As this breaks down as you get older, this can be why you have knee pain or joint pain, why you might need a replacement. Right near your epiphyses are your epiphyseal lines. This is a thin remnant of the epiphyseal plate, which is hyaline cartilage that you would have if you were still growing. But as an adult, they turn into a hardened line. And then in the middle, you have your medullary cavity, which is a storage area for fat. In infants, this is filled with red marrow that helps make blood cells. But in adults, you only find red marrow in flat bones and in the epiphyses of long bones. On bones, you have bone markings, which we reviewed in class. This can be where muscles, tendons, and ligaments attach. Those would be projections and processes that grow out from the bone surface. Those can also be found at joints. Or it can be where blood vessels and nerves pass, and those would be depressions and cavities or indentations in the bone. So as we go into the microscopic anatomy, we're going to discuss compact bone. Compact bone is actually very complex. It has many passageways that carries nerves and blood vessels in it, and those provide bone cells with an area for nutrients and waste disposal. So compact bone is made of osteocytes, which are mature bone cells, and then between those you have lacunae, which are tiny cavities within the bone matrix. Lacunae are arranged in concentric circles called lamellae, along with the osteocytes. And they're around a central canal called a Haversian canal. All of this together makes up an osteon or Haversian system, which is very complex, and it consists of the central canal with concentric circles around it, so matrix rings, almost like the rings of a tree. Canaliculi can also be found, and those are canals that radiate outward from the central canal to all the lacunae. And you can find perforating canals as well, and those create a communication pathway that are from the outside of the bone to the interior of the bone. Those canals will run at right angles to the shaft of the bone and go all the way through. In the bone, you're going to find calcium, and that gives the bone its hardness, but you'll also find organic molecules like collagen, which give bone its flexibility and its ability to stretch. So both of those are really important qualities of bone, the hardness as well as the flexibility. When your bone is forming and growing and remodeling, you have a lot of bone formation or ossification occurring. When you're a fetus, your bones are made mostly of hyaline cartilage, which are covered by a bone matrix or a bone collar. And in that bone collar is osteoblasts, which are bone-forming cells. And by the time you're born, most hyaline cartilage has been converted to bone, except for the articular cartilage on your joints and the epiphyseal plates, where your bone is going to grow. And then as you're growing, you're continuously making new cartilage, and that old cartilage is being broken down and replaced by bone. So it's ossifying until your adolescence and you stop growing, and then you just have an epiphyseal line. As you grow, bones also widen, so they don't just grow in length, but they widen. And so what happens is the osteoblasts add bone tissue to the diaphysis. As your bones grow wider, the osteoclasts are going to remove bone from the interface so that your medullary cavity also grows wider. So this is called appositional growth. It's controlled by your hormones, and it ends during adolescence. But your bone is going to be dynamic and active through your whole life. And bone changes in response to two things: calcium levels in your blood. If there's a lot of calcium, you'll have more bone deposited. Not very much calcium, you remove bone, which is why some people get osteoporosis. As well as the pull of gravity and muscles on your skeleton. So if you're going to take up weightlifting, it's going to affect not only your muscles, but also your bones, and it can strengthen them. And so those two things work together in determining when to add or remove bone, as well as where to add or remove bone. This is bone markings, which we reviewed in class, so make sure you review that chart. And then finally, bone fractures. There's two major types, which are closed and open. A closed or simple fracture is when the bone cleanly breaks and does not penetrate the skin, whereas an open or compound fracture is when broken bones penetrate the skin or go through the skin. Both are treated by reduction, which is when the bone ends are realigned and matched up, and there's a 6 to 8 week healing time with bone fractures. The process of repairing bone fracture has 4 parts. In the first part, a hematoma forms, which is when the site swells with and is filled with blood because of some ruptured blood vessels. Then a fibrocartilage callus will form, and that's the repair tissue, and it contains elements that will splint the bone. Then that will be replaced by spongy bone, and you'll have a bony callus, and as that remodels, you'll have a permanent patch where your bone has been healed. And finally, you can review this in your book, but these are the different types of fractures, more specifically, that you can have, and they're each caused by a different pressure or force that's on the bone. So you can review that chart in your book. So those are your notes, and if you have any questions, please write them down and bring them to me next class. Thanks, guys.